Hello, my dear students of class 12. Assalamu alaikum. How are you? I hope all of you are well. By the grace of Almighty Allah, I am also fine. Welcome to our today's class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. Today, I will discuss about your higher mathematics, exercise 9b, example number 2. Now, question is, if a particle moving along a straight line with uniform acceleration f, describe the successive equal distance in times t1, t2 and t3, then prove that this condition. Just you think this particle moving along this straight line. Okay, just you think the particle moving start from A with inertial velocity u, and after time t1 then he will be reached at a point B where the velocity will be u1, and then time t2, after time t2 then he will be reached at a point C, then velocity will be u2, and for the time t3 then you will be reached at a point D. The velocity will be u3. Okay, but the equal distance for each time interval, and let this equal distance is s. Okay, let this equal distance is s. Now we can describe this information by this figure. Let the particle moving with initial velocity u at point initial velocity u from the point A. Okay, here AB is equal to S, BC is equal to S, and CD also be S. Okay, equal distance for each case. Okay, now the time for AB is equal to T1, BC is equal to T2, and CD is equal to T3. Okay, for the time for AB distance is equal to T1 and BC distance is equal to T2 and CD distance is equal to T3, and velocity at point B, C, D at velocity for point B, C and D are at point B velocity is u1 and u2 and u3 respectively. Okay, this is our description for this information. Now we want to find out the average velocity for BC, AB, for BC, for CD. Okay, so we want to find the three average velocity for AB, BC, CD and finally for AD. Okay, Now average velocity for AB. Okay, average velocity for AB. Just average velocity for AB. Average velocity for AB. Distance is as time is t1. So velocity is equal to distance divided by time is equal to this here. At a point A, initial velocity is u, and at a point B, initial velocity is u1. So average is u plus u1 divided by 2. This velocity is equal to u plus u1 divided by 2. And total distance and time. This is velocity, average velocity, and by the u plus u1 is equal to this. Okay. Now this is for equation 1. Now for BC, average velocity for BC. Average velocity for BC. Okay. Distance is s, time is t2, and velocity u1 plus u2 divided by 2. This is equation number 2. Now average velocity for CD. Okay. Also time is s, distance is s, time is t3. So velocity u2 plus u3 divided by 2. This is equation number 3. Now average velocity for AD, total time, total distance, and total distance is AD. Okay. Then as time is t1 plus t2 plus t3, 3 time interval. So for the total journey, time is t1 plus t2 plus t3. Okay. t1 plus t2 plus t3 divided by their inertial velocity u and final velocity is u3. So u plus u3 divided by 2. This is equation number 4. Okay, we want to prove this expression. So 1 by t1 minus 1 by t2 plus t3. From this expression, it is clear equation 1 minus 2, because t1 minus t2, 1 by t1 minus t2 for equation 1 minus 2, and then equation 3. Okay, so equation 1 minus 2 and equation 3. Okay, so equation 1 equation 1 minus 2 we get from equation 1 minus 2 plus 3. Okay, equation 1 as divided by t1 minus as divided by t2 plus as divided by t3 is equal to u plus u1 divided by 2 minus u1 plus u2 divided by 2 plus u2 plus u3 divided by 2. Okay, now now in right hand side this is equal to LCM is 2, so u plus u1 minus u1 minus u2 plus u2 plus u3. Okay, then u1 and u1 will be removed, and u2 and u2 also be removed. Then remaining term is u and u3 divided by 2. And now here u plus u3 divided by 2 by using equation 4 is equal to this. Okay, so as divided by, here this is equal to 3. This will be 3, not as, because total for the total journey AD is equal to, this is wrong, it will be 3s, because for all distance, for the total distance, 3 successive equal distance. For AB is s, for BC is equal to s, for CD is equal to s. So s plus s plus s, 3s divided by T1 plus T2 plus T3. Okay. Okay, so we can by using this equation 4 is equal to 3s divided by T1 plus T2 plus T3. Okay, then here s divided by T1 plus minus s divided by T2 plus s divided by T3. Okay, here taking s as a common, then s into 1 by T1 minus 1 by T2 plus 1 by T3 is equal to 3s divided by T1 plus T2 plus T3. For the both sides, dividing by s, then we get 1 by T1 minus 1 by T2 plus 1 by T3 is equal to 3 divided by T1 plus T2 plus T3. So this is our condition for proof. Okay. Question number 41. A train starts from the rest along a straight line from one station and come to the rest at the other station. Okay. It moves from the first portion 1 by m part of the whole distance with uniform acceleration, and 1 by nth part of with the uniform retardation, and the rest of the distance with uniform velocity. Prove that the ratio of the greatest velocity and its average velocity is this. Okay. Just the train journey start with point A and come to the rest at a point D. Okay. Let the train start journey let the train start journey with from the point A from the station A to D. So in this position velocity u is equal to 0, because start from the rest position and come to the point also rest position, then the final velocity is also be 0. Okay, then the first portion of his journey 1 by m part of the distance, let the total distance distance is equal to d. Total distance is equal to D. And first part is AB. 1 by mth part, first portion is, let's say, is 1 by m, total distance. So m divided by d. First portion is m, d divided by m. D divided by m, because 1 by mth part of whole distance is d. So 1 by mth part of distance, 1 by mth part of distance is equal to d by m. Okay, and this journey using the uniform acceleration. Okay, just say time is t1. Okay, and then 1 by nth part of distance is equal to d by n, and this is the 1 by n part with the uniform retardation, last portion. The last portion of the journey, just say it CD n divided by d divided by n. Let's say time is for BC time is T2 and for this time is T3, and the remaining part is BC with uniform velocity. Just this velocity is u, and this also is, this velocity is b, and this also is b, because this is uniform velocity. Velocity will not be changed from b to c, because the remaining portion with uniform velocity. That's why at point b velocity is b, and also at point c its velocity is b, because this is the remaining portion. So remaining part is equal to BC is equal to, total distance is d. So with discard from first and last portion, then remaining portion is equal to d by m minus d by n. So this is remaining portion, this distance is d minus d by m minus d by n. This is the remaining portion. Time is t2. Now we want to calculate the average velocity for each case and for each case. Okay, now average velocity for AB. Okay, then time is t1, t2 and t3. Time for AB is equal to t1, BC is equal to t2, and CD is equal to t3. Okay, for this journey highest velocity is v, because this is the highest velocity, and starting inertial velocity is 0, and this is the highest velocity. And for BC using this velocity, and this is uniform velocity is v, and their final velocity is 0. So highest velocity for this journey is v, and average velocity is we can find for AD. Okay, now so highest velocity, the greatest velocity, the ratio of the greatest velocity at its average velocity. So greatest velocity is equal to b, and average velocity CT is equal to average velocity, let's say W is equal to total distance is d, and total time is t1, t2 and t3. So t1 plus t2 plus t3. Let's say T is equal to T1 plus T2 plus T3. So D divided by T is this is the average velocity W, and the value of this is D divided by T. Okay. Now average velocity for AB. Okay. Now average velocity for AB. The greater than, we want to the ratio of V is to W is equal to this. Okay, this is our flow. The ratio of greatest velocity and average velocity. That means V is to W is equal to this. Okay. Now the average velocity for AB. Average velocity for AB. AB is equal to AB average velocity. Distance is D divided by M time is T1. So velocity is equal to D divided by M time is T. So velocity is 0 and velocity is B. 0 plus B divided by 2. Okay. Now D by M into 1 by T, that means MT is equal to B divided by 2. So MBT is equal to 2D, and here this, and we get from this is time T1, or this time T1. Okay, so BT1 is equal to 2D divided by M. This is equation number 1. Average velocity for BC. For BC, then distance divided by time, D minus D by M plus D by N divided by time is T2, and velocity is V divided by B divided by 2, because their two velocity are equal. Okay, so D minus D by M plus D by N is equal to, this is V and BT2. So BT2 is equal to D minus D by M minus D by N. This is equation number 2. Now average velocity for CD. Okay, average velocity for CD. Okay. And then velocity B, time distance is D by N, time is T3. Okay, this is equal to velocity B plus 0 divided by 2. This is average velocity, and it can write D divided by N T3 is equal to B by 2 and B T3 by the cross multiplication 2D. And then BT3 is equal to 2D divided by N. This is equation number 3. Now adding equation 1, 2 and 3. Okay. Now adding equation 1, 2 and 3. Okay. Now adding equation 1, 2 and 3. Okay. For your easy information, we can write equation 1 is adding equation 1, 2 and 3. Okay. Adding equation 1, 2 and 3, the left hand side of equation 1 is b t1 and 2 is b t2 and b t3, and this is right hand side of equation 1 2d divided by m, and equation 2 d minus d by m minus d by m, and right side of equation 3 is 2d divided by n. Now taking b as a common from left hand side, t1 plus t2 plus t3 is equal to here 2d divided by n m minus d by n by this only d by m. Okay, n divided by n, 2d divided by n, only d divided by n plus d. Okay, by this is t, capital T, because this is t, and taking d as a common, 1 by m plus 1 by n plus 1. Okay, and here t is equal to t1 plus t2 plus t3. Okay, and now b into t divided by d is equal to 1 by m plus 1 by n plus 1. Now we can write this in left hand side b. If this is this term will be denominator, it will be d divided by t is equal to 1 by m plus 1 by n plus 1. Okay, now from the first step of this math, this is average velocity for total journey, which we can say is w is equal to 1 by m plus 1 by n plus 1. So this is highest velocity, this is called average velocity. The ratio of this is equal to 1 by m plus 1 by n plus 1, and is to 1 because the denominator is 1, you can say. So b ratio অর্থাৎ greatest velocity ratio to average velocity is equal to this ratio is to 1. This is our fruit. Okay, my dear student, this is our today's class.